1988, a discovery was made that would completely transform how we store and read data, ultimately enabling the creation of smaller, more powerful hard drives and the explosion of digital information we see today. This breakthrough came from the work of French physicist Albert Fert, whose pioneering research in spintronics opened an entirely new chapter in the world of electronics. Born in 1938 in Carcassonne, France, Albert Fert showed early promise in the sciences. After completing his education at École Normale Supérieure in Paris, he pursued a career in physics, eventually becoming a professor at the University of Paris-Sud. It was here that Fert began exploring the fundamental properties of electrons that would lead to his groundbreaking work. While conventional electronics relies on the charge of electrons to transmit information, Fert focused on another intrinsic property of electrons called spin. Spin can be visualized as a tiny magnetic moment, with electrons acting like microscopic magnets, pointing either up or down. This property had been largely overlooked for practical applications until Fert's research demonstrated its enormous potential. The watershed moment came when Fert discovered the phenomenon known as giant magnetoresistance, or GMR. Working with specially designed materials consisting of alternating thin layers of magnetic and non-magnetic metals, Fert observed something remarkable. The electrical resistance of these multi-layered structures changed dramatically, depending on whether the magnetization of adjacent layers was parallel or anti-parallel to each other. This effect was not just academically interesting, it was massive compared to previously known magnetoresistance effects, hence the name giant magnetoresistance. The practical implications were immediately apparent. GMR could be used to detect very small magnetic fields, making it perfect for reading data stored as magnetic regions on hard drives. The impact of Fert's discovery was swift and profound. Within just a decade, GMR sensors became the standard technology in hard disk drives, enabling storage capacities to increase exponentially. This technological leap allowed for the miniaturization of storage devices while simultaneously increasing their capacity, a development that directly enabled the creation of portable music players, smaller laptops, and eventually the massive data centers that power our digital world. For his revolutionary contribution to physics and technology, Albert Fert was awarded the Nobel Prize in Physics in 2007, sharing the honor with German physicist Peter Grünberg, who independently discovered the same effect. The Nobel Committee recognized how their work had launched the field of spintronics and fundamentally changed data storage technology. Beyond GMR, Fert's pioneering work established spintronics as a vibrant field of research and development. Today, scientists and engineers continue to build upon his foundation, exploring new spintronic phenomena and devices that may one day lead to even more efficient computers, quantum computing applications, and novel forms of electronic memory. Albert Fert's legacy extends far beyond academic physics. Every time we stream a movie, access cloud storage, or use a smartphone, we're benefiting from the technological revolution he helped initiate. His work represents one of those rare scientific achievements that bridges fundamental research and transformative real-world applications, changing not just our understanding of electron behavior, but reshaping the very infrastructure of our information age.